All right, good afternoon and welcome to Master Talker Online class. Today, let's continue with our video on statistics. So we have talked about mutually exclusive events. So let's talk about non-mutually exclusive events. Please, if today is your first day of watching us, consider subscribing. Please, just click on that subscribe button and then turn on your notification bell so that anytime we drop a new video, YouTube will notify you. Okay. So now two events A and B. Okay, two events A and B are not mutually exclusive if both events share something in common. Whenever they have an intersection, they share something in common, then we now say that they are non-mutually exclusive. So we say that two events A and B are non-mutually exclusive. Okay, don't forget that in mutual exclusive, that their intersection is an empty set. Please don't forget. I don't know if I mentioned it in the other video, but in mutually exclusive, their intersection is not empty. They have an intersection. They have something in common. Okay, so they have something in common. So mathematically, so since they have something in common, it means that their intersection is not empty. Their intersection is not an empty set. Okay, then we say that it is what? Non-mutually exclusive event. So, but we know that mathematically, we know that the probability of A or B is simply the probability of what? A union B. A union B. And probability of A union B is simply probability of A plus probability of B, then minus probability of what? A intersection B, what they have in common. And don't forget that what they have in common is not empty. So this is the answer of probability of A or B for non-mutually. That is, they have something in common, non-mutually. So if you draw using Venn diagram, you are having that this is the universal set, and I have that this is set A and set B. Okay, you see that they have something in common. They have something in common. Okay, so let's take an example so that we understand what we are talking about. Example, they say that if an event A implies obtaining prime numbers and B is now event, okay, and event B implies obtaining an odd number. Okay, in a single throw of a die, then they now say find the probability of event A or B. Solution. Now this is the sample. A sample is what? 1, 2, 3, 4, 5 and 6. And event A, if you look at event A, is another set, and they say event A is a set of prime numbers. 1 is not a prime number, but I have 2, 3 and 5. These are prime numbers. And B, if you look at event B, they said are odd numbers, which is 1, 3, 5, 1, 3 and 5. But if you look at, they have something in common. That A intersection B is a set that they have something in common. They have 3 and 5 in common. Okay, so probability of A or B is now probability of A plus probability of B, okay, minus probability of A intersection B. So probability of A is how many they are. that is 1, 2, 3. That is 3 over 6. 3 over 6 plus probability of B, the same 3 over 6. Then minus the intersection is what? 2 over 6, the total. So that is that. So you now see that the answer finally becomes probability of A or B simply becomes, the LCM is what? 6, which is 3 plus 3 minus 2, which is what? 4 over 6, which is what? 2 over 3. As simple as that. Okay. Okay. So the next one, okay, they say, note when any of the word or either is used, students should just jump into solving for addition. Rather, students should not just jump into solving addition. Rather, they should first identify if the problem is mutually exclusive or not mutually exclusive. So you need to know that if you hear or, either or, and I thought that or is just what? Addition. But before you do that addition, first of all, note if that event is what? Mutually exclusive or not. Please, very, very important. Look at this example. They said there are 12 cards, okay, numbered 1 to 12. Full stop. A card is selected at random, comma, okay, full stop. What is the probability that it is either, even or a perfect square? So solution. So the sample space is simply 1, 2, 3 up to 12. Let me call event A. Event A is the first one that said even numbers, which is 2, 4, 6, 8, 10, and 12. Okay. Event B is now perfect square. Perfect square is 4 is a perfect square. Any other perfect square? Only 4. If you look at that, only 4 is a perfect square. Is it not? Okay, 9 is a perfect square. Sorry. 9 is a perfect square. 4 and 9 are the only perfect square we have here. Okay. So if you look at this, they have something in common. So this is not just addition, but it is what? Non-mutually exclusive. Non-mutually exclusive. So you now say that what? The probability of A or B is simply the probability of A plus the probability of B minus the probability of A intersection B. And the A intersection B is simply 4 that they have in common. So what do we have now? So probability of A, how many are there? 1, 2, 3, 4, 5, 6. 6 over 12. Plus, the other one is 2. 2 over 12. Minus 1 over 12. So I'm having 6 plus 2 minus 1 over 12. Which is what? 5 over 12. It'll be 7 over 12. So that is that. So now let's talk about the multiplication law. We have talked about the addition law. And in the addition law, you must check if they are mutually exclusive or not. So now let's move into multiplication law. We call multiplication and multiplication law. Okay, we call it and. So under multiplication law, there is also two concepts of independent and dependent events. Okay. Under here we have two, like in the other one. In addition, what we have is mutually and non-mutually. But in multiplication, what we have is what? Dependent and independent. Independent and dependent event. So please, you need to know these two things, very very important. So let's talk about the first one, independent event. Okay, so two events A and B are said to be independent of the occurrence or non-occurrence of events. A does not affect the probability of the event B. A does not affect the probability of the event B. Okay? You know, from the word independent means that they don't depend on each other. They can just happen like that. You don't need this one for the other one to happen. So for that, we have that the probability of A and B. Okay, A and B is, remember that and means the intersection, but or means the union. Okay, it's simply probability of A times probability of B. That is, they don't depend on anybody to happen. Okay, and that is probability of A and B means intersection. A intersection B is simply probability of A times probability of B. So that is that. Now let's solve an example to that so that it will help us to understand what we are talking about. So example, the first example said that there are, okay, they say three balls are drawn successively from a box containing 8 red, 6 white and 4 black balls. Then find the probability that they are drawn in order. In this order: red, white, and black. If each ball is replaced, okay, if each ball is replaced, okay, now when you talk about independent event, we are talking about replacing it. But if they say that it is not being replaced, then we are talking about dependent event. So solution. So let's talk about when it is being replaced. If it is being replaced, so we are choosing, that is the probability of red first, and white and black. So which is what? Probability of red times probability of white times probability of what? Blue. So my answer is now probability of red is 8 over, how many are they? They are 18. 8 over 18 times this one, how many are they? 6 over the same 18. Why am I using 18? Is that after choosing, I will put it back again, so it is still complete. Okay, times the next one is what? 4 over 18. So if you do that, you are getting 8 over 243. Okay, some will cancel out each other, like 2 will take care of 2 here, you have 2 here, 9, 2 here, 3, 2 here, 9, 3 here, 1, 3 here, 3, 2 here, 4, 2 here, 9. So 2 times 4, 8. 3 times 9 times 9, 49. 49 times 3, 247. 243. So that is that. So let's take another question. So the next question we'll look at is a box. A box contains two red balls, comma, 4 blue balls. Okay, a ball is drawn. A ball is drawn at random. A ball is drawn at random from the box. Okay, and then replaced. And then replaced. And I told you that when it is replaced, that you are talking about what? Independent. So, and then replaced before a second ball is drawn. Okay, find the probability of drawing two red. Find the probability of drawing two red balls. Okay, solution. Okay, so since we are drawing two red balls, solution. Okay, and the solution is just that the probability of drawing a red ball at the first one and then the same red ball at the second one. So, and don't forget that you will replace it. So it is just the probability of drawing a red and the probability of drawing another red. Okay, so which is what? Probability of drawing a red is 2 over how many? There are 6. 2 over 6 times, you know that and means times 2 over 6 again, because it is replaced. That is 4 over 36, which is 1 over 9. Okay, 1 over 9, as simple as that. So let's solve 2 more questions and then we move into without replacement. So the next question we will look at is a fair die. Okay, a pair of fair dice with each face numbered 1 to 6. With each face numbered 1 to 6 are thrown once. Find the probability of scoring 2 on one die and a 5 on the other. Solution. Okay, now this is probability of obtaining 2 and what? 5, which is what? Probability of obtaining 2 and probability of obtaining 5. Why? Because there are 2 of them. There are 2 that is being thrown. So in the other one there is complete and the other one is still complete. So you are not removing from any one and the one is missing. So probability of getting 2 is just 1 over 6. Time probability of getting 5 is just 1 over 6. Because they are just 1 to 5. Look at what I'm saying. 1, 2, 3, 4, 5, and 6. This is the first one. 1, 2, 3, 4, 5, and 6. The first one. In the first one, we got 2. How many 2 is there? 1 out of 6. In the other one, we got 5 out of 6. Okay, so which is what? 1 over 36. As simple as that. So the next one, I think the last question I'm going to solve here for multiplication, said a bag a bag contains three black and 2 red balls. A ball is picked at random from the bag and then replaced a second ball is chosen at random again, comma, what is the probability that a question they are both black? B question, one is black and one is red. One is black and the other red. Solution. Now for the first one, if we pick, that is the probability of, if we pick the first one and it is black, and then you pick the second one and it's equally black, which is what? Probability of black and probability of black. Why? Because they are being replaced. Okay, there is a replacement. Since there is a replacement, probability of black is 3 over what? How many are there? 5. And we now put it back, so they are now still complete again. You pick again, you are picking the same 3 over what? 5. So which is 9 over 25. Okay, so but the second one is that you pick a black and then the next one you are picking becomes red. Becomes red. So which is what? Probability of black and probability of red, which is what? Probability of black is 3 over 5 times 2 over 5, which is what? 3 times 2, 6 over 25. As simple as that. So these things are very, very simple. So now let's go to irreplaceable. That is a dependent event. Okay. Now for dependent, they say 2 events A and B are said to be dependent if the occurrence of A affects the occurrence of what? Of B. Then we now say that the probability of A and B, okay, is simply the probability of A times, okay, times the probability of B over A. B slash A. And you know what is slash? Slash means minus. Slash, not divide. Slash means minus, please. So which means probability of A intersection B is simply what? The probability of A times probability of what? Of B slash A. Don't worry. I will explain when we are solving problem, okay? But in an independent event, B slash A, it doesn't work there. Don't forget. And then we use the word replaced. We use the word what? Replaced. So let us still solve that question. That's formal question. Look at this question. This question said, you can go back. That question I said, three balls are drawn successively, okay, from a box containing 8 red. Number of red is 8. 8 red and 6 white. Number of white is 6. And then 4 black. Black is 4. Okay, they say find the probability that they are drawn in order red, white, and black. Probability of what? Red, white, and black. And then the first one we said is what? When they are replaced. Then the next one we will solve now is now what? Without replacement. Now you can go back to get with replaced when it is being replaced, but without replacement is simply, now we are picking the first one, probability of red, white and black is simply probability of red first. Okay, probability of red first times where am I talking about? So if we pick red, it is what? That time they are still complete. 8 over. The total is how many? The total is 18. Okay. I have picked one and I did not replace it. So red is no longer complete. But the next one, white is complete times white is complete, but the total number now will now be 17 times we have taken 2 out now. Blue is complete, but the total number is now 16. So that is that. If you multiply everything now, you are getting 2 over 51. Okay, so do that. Some things will cancel out, then you get 2 over 50. As simple as that. Okay. Okay, so let's take another question. The second question, number 2. Number 2 said a science class containing 2 boys and 8 girls. 8 girls all participated in an end of the year quiz. Okay, then I say find the probability of choosing both slots A and B by girls from the group, to represent the college at the local government level. Okay, solution. All these ones they are talking is story. Now for the first slot, that is the probability of, for the first slot you are taking a girl, and the second slot you are still taking a girl again. So which is, and then when you take a girl you did not replace, you have already taken that girl out. So if the first slot now I'm taking one girl, which is what, 8 over what, the total 10 times the next girls are now there's one is already out of the girl, so the girls are remaining 7. So it's remaining 7 out of the total number is no longer 10 but what, 9. So that is that. So the answer I'm having is so do that, you have, I think, 56 over 90. As simple as that. 56 over 90. So the next question, we'll solve just 2 more questions on that and then we are good to go. So let me check my time. Okay, so let's just solve 2 more questions on that and then we are good to go. The next question said a bag contains 9 identical balls. 9 identical balls. Okay, 9 identical balls, out of which 3 are blue, 2 are white, and the remaining are red. Okay. Okay. Then I say if two balls are drawn at random, one after the other, comma, what is the probability that both of them will be red, comma, if there is no replacement? Solution. Okay, so now we want to pick. Now we pick the first one and it is red. We are picking the second one and again we pick the next one and it's equally red, and then we did not replace. So how many red do we have? 2 are blue, 3 are blue, 2 are white, and then the remaining is red. If the remaining is red, I'm having 2 plus this is 5, so 9 minus 5 is 4, so I'm having 4 red. That is 4 over how many are they? 9. I have picked the first one, then picking the next one, 4 will reduce to 3, and then the total will now reduce to 8. So if you do the math, you are having I think 1 over 6. As simple as that. 1 over 6. Okay? Okay, 3 here, 1, 3 here, 3, 2 here, and this is 2. 1 over 6. Okay, so the last but not the least question. The last question here said a packet contains 4 red, 5 blue, and 6 black identical biros. Okay, 2 biros are picked at random without replacement. Okay, find the probability of picking a red and a black biro. Okay, solution. So if I'm picking the first one, I'm picking a red, but the second one I'm picking a black. So if I pick a red, it's going to be 4. That's 4 red over the total 15 times 1 is already out of 4. Okay, so the total is now 14. But the next one I'm picking is black, and black is 6. That is 6 over 14. Okay, if you do the math now, you are having 4 over 35. Okay, so thank you very much for watching. Please consider subscribing and share to anyone that likes that need the video. Please drop your comments at the comment section. God bless you.